Hello everyone. Today we will discuss tree problem, LeetCode problem 652, find duplicate subtrees, and we use recursion plus memorization solution to solve it. Firstly, let's see the description of this problem. Given the root of a binary tree, return all duplicate subtrees. For each kind of duplicate subtrees, you only need to return the root node of any one of them. Two trees are duplicate if they have the same structure with the same node values. Okay, let's see our solution. We use the recursion plus memorization to solve the problem. We use recursion to traverse the tree and to serialize the trees for each node as the root, and then we store the serialization strings for the trees in a hash map. And we have a Python list to store the final results here, and we have a Python dictionary to store the serialization strings, and the key is the serialization strings for the trees, and the value is the number of appearance of the serialization strings. Then we explain the serialization. So we have count for null nodes, and then for the trees for node 3 will include the node itself and the left child and the right child. We use the pre-order traversal, so the sequence of the serialization string will be firstly the node and then the left subtree and then the right subtree at last. Okay, so for the structure for the tree and the node 3 as the root is 3 now. So we have the serialization string here as 3 comma pound comma pound. Okay, then we say the serialization for this node 2 as the root will be firstly the node itself, node 2, and then the left subtree, so the 3 pound, and then the right subtree pound, and so on. So here we explained how the serialization works. We have the pound as the null child here because we want to differ the like 2, 3 here, and another very similar structure. So if we have another node 1 here as the node as the left child of the node 3, so another 1 here, then the 2, 3 and then the 2, 3 looks very similar, but they are not the same because for the 2, 3, 1 tree, the structure should be 2, 3, 1 now and now, but here is 2, 3 now. So we need to have the pound sign here to stand for the null nodes. This is a very tricky corner case. Okay, so we have the serialization for the current node, and the serialization will be a parameter to pass to the next iteration. And here is like we firstly get the serialization of the children nodes, and then for their parents nodes, we will pass the serialization of the children nodes to the parents nodes. So here, for example, firstly, we get the serialization for next node 3, so 3 pound pound. And then for next node, node 2, we pass the 3 pound pound to it. So for next one, the path will be the current node 2 here. Here is like the star here is like we transfer the value of the node to a string. So here is the value of the node 2, and then we will get the serialization of its left subtree. So here we will pass the 3 pound pound to it. So then here will be 2 for the root node, and 3 pound pound as the left subtree, which is passed from the children node, and then the right subtree here is 1 pound here. Here we print the path we construct for each recursion iteration, and it can help us better understand how the recursion works. Then we store the serialization string, which is the path, in the hash map. So if the path is already in the hash map, then the path appears once again. So we plus 1 to it, so to the value, and here we explained before, the value is the numbers of appearance of the serialization string. And if the number of appearance of the current path equals 2, which means we have 2 exactly same serializations, so these 2 will be duplicates. Then we append the node in our final results here. Then if the appearance of the path is larger than 2, so because we've already appended the results, so we don't need to append the results again. And if the path is not in the hash map, we set the number of the appearance is 1. So here we have 1 here. And then we return the path, which is the serializations for the current node to next iterations, which will be in the parent nodes for the current node. And by doing this, we will get the result. And we can have the example here, because we print the path here. Here is our print results. So in the first iteration, we have this node 3, and then the serialization for it is 3 pound pound, and then in next iteration we have this node 2, and we have 2 as the root value, and we have the 3 pound pound because we have the recursion node left and the path here. So we have 3 pound pound here as the path to be passed to the to current iteration, and for the other one we have no null node, so we have another pound here. And then for next iteration, which we handle this node 3, and so it's a 3 pound pound, and then for next we handle this node, and so we have 2 3 pound pound and pound. So here we say 2 3 pound 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 and 2 3 pound pound as the duplicate, and then we have the last node 2, and then the serialization is 2, and the serialization of this subtree as the this current node 2 as the root, so it's like 2, 2, 3, pound, 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 and then the right subtree is 2, 3, pound, pound, and pound. So then we finish our entire solution. Actually, the recursion plus memorization is very, very similar to the dynamic programming solution. So our solution is very similar to a dynamic programming bottom-up solution. And our time complexity and the space complexity is O(n), because as we can see our print results here, for each node we only traverse once. Here like 3, pound, pound. For this node is 2, 3, pound, pound, pound. And here we can see every node we only traverse once. And then because we store our serialization strings in our hash map, and then from children child to pass to the parents nodes, then we only store the strings in a hash map, so the space complexity can also be O(n). And this one is very tricky. If you can understand the recursion and the memorization very clearly, and which means you will be very good for binary tree problems. Good luck. Bye bye.